Lesson 27, Identifying Misleading Representations of Data. Scalar labels can make a graph misleading. For example, we have this graph. Let me get it written out here. For example, we have this graph that we can tell is about the number of members at a health club. And on our y-axis, it says the number of members. So we have 600, 700, 800, 900. And then we have January, February, March, April, May, and June. Okay? And what we want to know is we want to know why this might be misleading. Okay? Some reasons that this graph in particular may be misleading is because of this right here. Okay? This is a broken scale. Okay, that tells us that it's not starting at 0, we're starting right here at 600. And the reason that this makes our graph look misleading is because it starts down here really low, and it looks like it's climbing really high. So actually, it looks like it's going from almost 0 to 900, when that's not the case. It's actually going from 600 to 900, where the line, if we had used smaller increments, we would be able to see that it looks more flat than what it does this huge increase. So it's because of this broken scale right here that this would be misleading. Okay, on example 2 we have listener music preferences. That's what this graph is about. We have the number of listeners, 0, 500, 1,000, 1,500, and the types of music, rock, pop, hip-hop, and other. And some reasons that this may be misleading. Number 1 is because of the scale. We are going in chunks of 500, which is not necessary because there is nothing that is above this 1,000 number mark. Okay, that means that we should probably do it in increments of maybe 250 and have 1,000 being all the way up here so that we can see an actual difference, because this one and this rock and other are just around that 500 mark, a little bit over, where pop, let me see if I can do this fairly straight. Can't. Alright. Is about halfway between. I've dropped down, I apologize, which would be about 750. So these are like 250 listeners apart, but it looks like there's barely a difference. And all the bars look to be about the same height. So we probably, even if we had gone with 100 scale and had 10 different things here with it going up to 1,000, that would have made it better too, because it could be more precise that way. Because like I said, this one's over 500, but I can't really tell how much over 500. And especially for this one that's all the way over here, it's really hard to tell. Example 3 shows the number of some types of sandwiches at, Example 3 shows the number of some types of sandwiches a deli sells in one day. And they have turkey, ham, roast beef, and tuna. And we want to talk about some of the reasons that this would be misleading. The big reason is because of this word some. Okay? What if they had a BLT, let's say, and they sold 100 of those? They didn't show it here. They only showed ham, roast beef, tuna, and turkey. But a BLT would have sold more than this, or if it was chicken or something like that. They didn't show every type of sandwich. And whenever we're talking about this circle graph, a pie chart, we are talking about the whole. This is not talking about the whole. And it also says, let me add one more thing, in one day. Okay? One day means that they chose one day to go and do this survey. What if it was the day that ham sandwiches were on sale, like at Subway, for example? If you go to Subway to get a sandwich, every day of the week they have a different special. Well, what if they chose the day that ham was a special? Of course more ham is going to sell on that day. But if you had went on a day that turkey was a special, they probably would have sold more turkey. So this is just really misleading. An electronics store created the graph to show the average selling price of a television each year. So they have average television prices here, dollars here, and the years. And they're ranging from the year 2000 to 2005. Okay? And it wants us to explain why the graph may be misleading. So let's first look at where our points are. Right here, which is about right between 500 and 750. This point that's close to 750. This point on 750. a little higher than 750. This is between 750 and 1,000, and then not quite 1,000. Okay? Well, the big reason, the most obvious reason, I hope, is because of these large scale. Okay? This large scale is throwing this whole thing off because we, again, nothing over 1,000. There's nothing up here in this range at all. And whenever you're going by these 500 increments, okay, or 250, I guess, because they do have the marks, it's not very precise because look at how little it looks like the price of a television has actually increased. Okay, when actually in 2000 it was probably around $600, and in 2005 it's almost $1,000. That's almost doubled in price, but that's not what they're showing here. What conclusion might be made from the graph? Well, if you were just looking at this graph and you paid absolutely no attention to the scale or anything like that, then you would probably say the price of a television has increased in the last 5 years, but not by very much. The other question on question B said, why might the store have created this graph? Well, if you're selling TVs, you don't want people to think that you've doubled the price of your TVs, right? You're wanting to sell more, so they're trying to show that we have hardly raised the price of a TV in our store. That's what they're showing here. What they're trying to show, when it's not actually the case. On C, it says to make a graph of the sales data that is not misleading. So this is something that I want you to do on your own paper. I would recommend using increments of about 100 instead, and have 10 different marks for them. And you're going to have to guess pretty close about where these things are. We talked about it, but you can get pretty close, and I want you to create your own on using a 100 increment scale. Oh, I guess that's it for today. I hope that you've taken good notes, and I will see you in class tomorrow.